our online chemistry class. Our topic is chemical thermodynamics. Let us see the next part number 5 of our topic. So our point is spontaneous irreversible process. So let us consider first what is the meaning of spontaneous process. So the process which can be takes place naturally, that process is called as spontaneous process. There is no external influence for their occurrence. So let us consider, all are familiar with the neutralization reaction. When sodium hydroxide react with hydrochloric acid, it gives sodium chloride aqueous plus water in liquid state. So this is the neutralization reaction, and heat of reaction or heat of neutralization is minus 57 kilojoule per mole. So carried out this reaction, if you simply mix these two chemicals, then the reaction will occur, and there is no external force to be required to carry out this process. That's why this reaction is spontaneous. So there are different examples of such a type. So all are familiar with that flow of water from higher level to lower level, it is also a spontaneous one. Okay, but if we have to flow the water from lower level to higher level, we have to use electrical motor, that is the external influence applied to flow the water from lower to higher. So that is not a spontaneous, that is non-spontaneous process. Okay, then ice can melt into water above 0 degree, so it is a spontaneous process. Then hot cup of tea or hot coffee in a cup placed in a room cools down by releasing heat to the surrounding, so it is a spontaneous process. Now there are some important features or key points. First one, it occurs of its own and does not require any external agency to occur. The reaction can take place naturally, or that process can take place naturally. Then second is, it proceeds in one direction and cannot take place in the opposite direction unless the external agency which will be applied or agency should be present. So if it is carried out in one direction, it is irreversible. That's why spontaneous process is irreversible and it is not reversible in nature. Then it can be rapid or sometimes it may be slow. So spontaneity of that change is not concerned with the rate of reaction. Okay, so it does not depends on the rate of reaction, and this process can be continued till there is equilibrium is achieved. So spontaneous or natural process tends to occur in a direction that leads to equilibrium. Now next point is energy and spontaneity. So for a spontaneous reaction to be carried out in a direction in which energy of the system is lowered or decreased, so it is accompanied by a release of energy or loss of heat. And if you observe the reaction between sodium hydroxide and hydrochloric acid, heat is given out, so reaction is exothermic and it is a spontaneous reaction. But if you observe, ice melts spontaneously above 0 degree by absorbing heat from the surrounding. Okay, so heat will be absorbed from the surrounding, so it is absorbed, so it is endothermic process. Okay, so here the spontaneity of the reaction is not only depends on the heat absorbed or evolved. Okay, now one more change. So if we add NaCl solid in water, and it will produce Na plus aqueous ion and Cl plus aqueous ion, then how much heat will be absorbed? It is 3.9 kilojoule per mole. So this indicates that heat is absorbed, and again reaction is spontaneous. So it is not only the criteria to decide whether that change or process is spontaneous or non-spontaneous. So spontaneity is not depends on the exothermicity of the process or that change. Now next concept, for that purpose one more concept is required, and that concept is called as entropy. So all are familiar with this diagram. Okay, so if you observe this diagram correctly, this diagram indicate the orderness and disorderness. So if you observe these molecules in solid state, so for example ice, these molecules are orderly arranged. So all of you learn about the characteristic of these molecules. In case of solid, they are orderly arranged, and if you observe that in liquid state, they are less orderly arranged, and in case of gaseous state, they are not in order. That means they are highly disordered manner. So these molecules are in highly disordered manner. So from ice to water and water to water vapors, so disorderness increases, and if the disorderness increases, that concept is called as entropy. More is the disorder, more is the entropy. So measurement of disorderness is called as entropy of the system. Okay, so definition is the disorder or randomness is called as, is measured by a term, that term is called as entropy. Measurement of disorderness is called as entropy. So melting of ice, vaporization of liquid shows disorderness. So if disorderness increases, entropy increases. So let us see some example. And if you observe the change in entropy, initial to final, when ice changes to water, then solid gets converted to liquid, orderness molecule get in disorderness. So delta S change means S for entropy in case of solid, entropy in case of liquid. Change is called as final minus initial. This entropy always increases, or if you consider from gases to liquid to gases, again entropy increases because disorderness increases. So let us see one example: dissolution of solid iodine in water. So if you add solid iodine in water, we get an aqueous solution of iodine. So initially it is solid, and the phase will get changed to liquid. So disorderness increases, so entropy increases. Now let us consider the bond dissociation between hydrogen and hydrogen in case of H2 molecule. So if you break the bond, that molecule gets separated into two hydrogen gaseous atom. So atomization is the process, and in this case also initially only one molecule is present, now there are two atoms, so disorderness increases. H2 molecule is stable, but H atom is not stable, so disorderness increases. This indicates that entropy also increases. Now can you try for this, state whether the change in entropy delta S is positive, negative or zero for the following reaction. So reaction first is H2 2H2 gas plus O2 gas gives 2H2O liquid. So check the changes. Reactants are in gas state, but your product in liquid state. So if you observe that previous diagram, in case of gases, more is the disorderness. In case of liquid, less is the disorderness. So disorderness decreases. That means entropy decreases. So here change is final minus initial. So your final is less entropy than the initial, so change is negative. Change is negative for this reaction. And in case of calcium carbonate, which is in solid state, gets converted to calcium oxide in solid state and carbon dioxide in gas state. So here your reactant is in solid state, and out of the two product, one in solid state but other in gas state. So remember that here carbon dioxide in gas state, so entropy of this CO due to this CO2, entropy of your product, that is in final state, increases than the reactant. So change is positive. Final minus initial is positive. Okay. So entropy of this is positive. So for second reaction, delta S is positive, but for first reaction delta S is negative. So this is about the entropy. Now quantitative definition of entropy. How will you represent entropy in mathematical form or in the equational form? So entropy is the measure of molecular disorderness or randomness. An entropy change of that system is equal to amount of heat transferred to it in a reversible manner divided by the temperature in Kelvin. So Q reversible is related to the amount of heat transfer, and T is nothing but temperature. So delta S is equal to Q reversible divided by T. So all are familiar with the unit of Q means heat, it is in joule, and temperature in Kelvin. So it is the unit for change in entropy, it is joule per Kelvin. Then entropy or its change is depends on initial value and final value. So it is a state function. It is a state function. Like your internal energy and enthalpy, entropy is also a state function. When heat is added to your system, the molecular motion increases to increase of their kinetic energy. If molecular motion increases, kinetic energy also increases, and this results into increase in molecular disorder. So if kinetic energy of that molecule increases, these molecules collide to one another and the disorderness increases, and this indicates that entropy of the system increases. So entropy of the system is directly proportional to Q. That's why it is written in the numerator in your equation 4.32. So you can check here, it is written to your numerator. And the effectiveness of the addition of heat, we have to check to increase the randomness, depends on the temperature. Okay, so let us consider the amount of heat is added to that system at higher temperature, then the disorderness due to that high temperature is very less in case of entropy. Okay, but if we carried out, if we supply same amount of heat but at low temperature, we observe that there is more disorderness as compared to at high temperature. You have to supply same amount of heat but at two different temperature, and if you observe that in case of high temperature, the disorderness is less than the disorderness at lower temperature. So this indicates that your delta S change in entropy is inversely proportional to temperature, and that's why it is written in denominator in your equation. Okay, so delta S is inversely proportional to T. So delta S is equal to Q reversible by T. So this is the mathematical equation for change in entropy. Now we have to discuss about the second law of thermodynamics, entropy and the spontaneity. So let us consider two examples. All are familiar with. First example, ice melts above 0 degree and water vaporizes at 100 degree. So these changes will occur naturally. So these are spontaneous. Let us consider the decomposition of H2O2 means hydrogen peroxide into water and oxygen. So if you observe here, hydrogen peroxide in liquid state but oxygen in gaseous state, and we observe the value of change in entropy is plus. This indicates that the disorderness increases, entropy increases due to formation of oxygen gas. So from this example, it is clear that entropy of the system increases in case of spontaneous process. Entropy of the system increases in case of spontaneous process. Let us consider another example. Formation of water from hydrogen and oxygen. So hydrogen and oxygen are reactant are in gaseous state, but your product, which is a water, in liquid state. So our change is from gases to liquid. So disorderliness decreases, so entropy decreases. So delta S is minus 327 joule per Kelvin. So it decreases. So but still reaction is spontaneous. It can occur naturally. So what is the second law of thermodynamics? It states that total entropy of a system and its surrounding increases in case of spontaneous process. So delta S total is equal to delta S system plus delta S surrounding, which is always greater than 0. So total entropy of system and its surrounding increases in case of spontaneous process. So the spontaneity of reaction is not only depends on the entropy of system. We can't say about the spontaneity if we know only the entropy of system. So that's why the sum of the entropy, that is system, entropy of system and that of surrounding, is considered, and if the total entropy is greater than 0, then we can say that the reaction is spontaneous. So in the previous example, your entropy, change in entropy is minus 327 joule per Kelvin, and if you observe that heat of reaction is minus 572 kilojoule, both at 298 Kelvin, then to find out the delta S total, means change in entropy for this system and surrounding, we must know the change in entropy of the surrounding. This value minus 327 joule per Kelvin is the entropy of system only, but we don't know the value of change in entropy of surrounding. But from the value of heat of reaction, we can calculate the entropy of change in entropy of surrounding. So here 2 moles of hydrogen and 1 moles of oxygen, they give 2 moles of water. So how much heat is given out? Because here negative sign is indicate that heat is given out. 527 heat is given out, and which is absorbed by your surrounding, but at constant pressure and at 298 Kelvin. So what is the entropy of surrounding? It is Q reversible divided by T. Q reversible divided by T. So it absorbs 572 kilojoule, means 572 into 10 to 3 joule. Okay, so remember this. Your value of entropy is in joule per Kelvin, but value of heat of reaction is in kilojoule. So while solving the numerical, always convert your heat of reaction in joule. So your answer for delta S surrounding is 1919 joule per Kelvin. So substitute this value and you can calculate the delta S total. So delta S system is minus 327 joule per Kelvin and delta S surrounding is 1919. So your final value for delta S total is equal to 1592. So here it is plus. This indicates that change in entropy of the total is greater than 0, and that's why the reaction is spontaneous. So this indicates that spontaneity of the reaction, we have to consider the entropy of the, we must know the entropy of system and the surrounding. We must know the entropy of the system and surrounding. We can't depend on the entropy of only system. Okay, because here entropy of the system is negative, but still your reaction is spontaneous. Still your reaction is spontaneous. So remember that entropy of the system is depends on entropy of system and surrounding. That's why the second law of thermodynamics is written, and which is based on the change in entropy. Delta S total is greater than 0. So the total entropy increases during a spontaneous process, and that finally reaches to equilibrium condition. So at equilibrium there is a maximum total entropy, and total entropy change must be 0 if your process is at equilibrium. So if delta S total is greater than 0, then your reaction is spontaneous. If it is equal to 0, then reaction is at equilibrium. If it is less than 0, then reaction is non-spontaneous. So here are the conditions. Delta S total is greater than 0, reaction is spontaneous. If it is equal to 0, then reaction or process is at equilibrium, and if it is less than 0, reaction is non-spontaneous. So remember the condition for spontaneity of reaction. So simply you have to remember only first condition, delta S total is greater than 0, then process is spontaneous. So it may be asked in multiple choice question. Now next point is Gibbs energy. Again important thermodynamic properties that we have to discuss. So if you observe the previous concept, we must know the delta S system and delta S surrounding for predicting the spontaneity of the reaction. But every time we must know these values. But to understood the spontaneity reaction in convenient manner, we must know one more property which should be thermodynamic in nature, and it was proposed by American scientist Gibbs, and that's why the property is called as Gibbs energy. And what is the definition? What is the mathematical form of Gibbs energy? What is the equation? G is equal to H minus Ts, where H is the enthalpy, T is the absolute temperature in Kelvin, and S is the entropy of that system. Remember that if the suffix or subscript word is not mentioned, yes, U double R, see here, yes, U double R is mentioned, then it is the entropy of surrounding. Up to this, we mention the entropy of surrounding by the word SYS, but nowadays, if the word SYS is not mentioned, or if there is no word after S, this indicates that this is the entropy of system. How will you calculate the change? Simply write down the delta sign before these terms. So delta G is equal to delta H minus T into delta S. Why T is kept outside? Why not delta T? Because here we have to fix the temperature. We calculate this change in enthalpy, change in entropy at a particular temperature. So temperature is also same. So T is written. There is no delta T. The change in Gibbs energy is equal to delta G is equal to delta H minus T delta S. Remember this equation. Then we have to find out the relation between Gibbs energy and spontaneity. So all are familiar with delta S total is equal to delta S system plus surrounding. So now we write the delta S system as delta S. Okay. Now relationship between delta G and delta S total. So we have to mention this condition. Delta S total is always greater than 0 for spontaneous reaction according to second law of thermodynamics. So if delta H is the enthalpy change accompanying a reaction or system, the enthalpy change of the surrounding is delta H but with negative sign. If delta H is positive for system, then for surrounding it is negative, so minus delta H. So what is the change in entropy for the surrounding, it is equal to minus delta H divided by T. Minus delta H divided by T. Now, if we substitute this value of delta S surrounding to above equation, then what is the equation 4.36? It is delta S total is equal to delta S minus delta S means delta S system plus delta S surrounding. So delta S total is equal to delta S surrounding is minus delta H divided by T. Now if we multiply whole equation by T to this 4.38 equation, then T delta S total is equal to delta H minus T delta S. Okay, so your equation becomes and you have to multiply with negative sign also. So delta S total, and if we substitute this value in 4.35, it is 4.35 delta H delta G is equal to delta H minus T delta S. Delta H minus T delta S is equal to delta G. So your delta G is equal to minus T delta S. Okay, so here minus sign is not mentioned. Okay, so minus, we multiply 4.38, then minus T delta S total is equal to T delta S minus minus plus delta H. So delta H minus T delta S is delta G. So delta G is equal to minus T into delta S total. Okay, so for spontaneous reaction, delta S total is greater than 0, but delta G is less than 0 at a constant temperature and pressure. This is the condition for spontaneity. So reverse is the condition. For spontaneous reaction, you have to remember that delta S total is greater than 0 and delta G is less than 0. If delta S total is less than 0, delta G is greater than 0, it is non-spontaneous. And if both are equal to 0, then process is at equilibrium. Now we have to consider the spontaneity and delta H or delta S. So from delta G is equal to delta H minus T delta S at constant temperature and pressure, we have to write some condition. So it is totally depends on the temperature. Okay, so first case, if delta H and delta S both are negative, if both are negative, and then if your delta S value is less than delta H, means it is smaller value, then it is positive. But when delta S is greater than delta H value, then your delta G will be negative. Okay, so that is the second case. Delta H and delta S both are positive values, then your delta G will be negative only when T delta S is greater than delta H. But this can happen when T value is higher. So we have to keep the temperature higher. Now, if delta H value and delta S value both are negative values, so negative negative become plus, and if this become plus, and if your delta H value is greater than delta S, that means if delta H is more negative, then and then this and this plus, which has less smaller value, then overall value becomes negative. But this can happen only when if T value is smaller, that means at low temperature. That is the first case. So delta H and delta S both are negative, then delta G will be negative only when delta H is more negative than delta T delta S, and this is possible at low temperature. So this is about the second condition. Then third condition is delta G will be negative if delta H is negative, delta S is positive. In all different cases of temperature, delta G is always negative. And if delta H is positive, delta S is negative, then delta J is always positive, because delta T minus T delta S become plus, and both value become plus plus. So in all case of temperature, reaction become non-spontaneous. Now next is temperature of equilibrium. So what is the your equation? Delta G is equal to delta H minus T delta S. So if we rearrange this, so if we transfer this delta H to this side, delta G minus delta H is equal to minus T delta S, and if we write the rearranging the equation, T is equal to, when we write delta G is equal to 0, if we write the equilibrium condition, this equation becomes 0. It becomes 0 when your equilibrium process at equilibrium. So 0 is equal to, this will be equal to 0. Okay, at equilibrium, then 0 is equal to delta H minus T delta S. So delta H is equal to T delta S. So T is equal to delta H divided by delta S. So temperature T is equal to change in enthalpy divided by change in entropy. So here we have to suppose that this change in enthalpy and change in entropy are independent of temperature. So it is the temperature at which, when there is change in process from spontaneous to non-spontaneous. Then Gibbs function and equilibrium constant. So delta G is equal to delta G0 plus RT ln Q. So where delta G is the change in Gibbs energy, delta G0 is standard Gibbs energy change. So if there is a 0 or that degree, then it is the standard value. So delta H0, like that. So for this, your reactant and product are in standard state. What does this Q indicate? It is a reaction quotient. So if reaction is at equilibrium, this Q is equal to K. K is the equilibrium constant. So now your Q is a reaction quotient and which contains the concentrations which are not at equilibrium condition. So the concentration involved in the Q formula is non-equilibrium concentration, or if we consider the partial pressure, they are at they are not equilibrium condition partial pressure, so they are non-equilibrium partial pressure. Let us consider the reaction. It is irreversible reaction. A moles of A plus B moles of B gives C moles of C plus D moles of D. So what is delta G? Delta G is equal to delta G0 plus RT ln Q C, in C for QC, the C for concentration. So delta G0 plus RT ln QC means concentration of C raised to C into D raised to D divided by concentration of A raised to A into concentration of B raised to B. These concentrations are not equilibrium concentration, they are non-equilibrium concentration. Or if we write partial pressure, then only the change in the here QP, partial pressure of C raised to C into partial pressure of D raised to D divided by partial pressure of A raised to A into partial pressure of B raised to B. These partial pressure of A, B, C, D are not equilibrium partial pressure. They are non-equilibrium partial pressure. If they are equilibrium pressure, partial pressure, then QP is equal to KP. If these are equilibrium concentration, QC is equal to KC. When your reaction reaches to equilibrium, then what you say? At equilibrium, delta G is equal to 0, not delta G0 is equal to 0, and QC and QP becomes KC and KP respectively. So our equation becomes 0 is equal to delta G0 plus RT ln KC, and 0 is equal to delta G0 plus RT ln KP. So delta G0 value becomes equal to minus RT ln QC or minus RT ln KP, or delta G0 ln means log to the base e. We change the base to log 10, multiply the equation by 2.03. So delta G0 is equal to minus 2.03 RT log KC, or minus 2.03 RT log KP to the base 10. So here we end the topic. Thank you very much.